Hey, it's the Boffin. Got another fun project here coming up. Have some problems in our server rack at work. I'm hoping this is going to solve it. A collection of goodies that I bought either just online or from the hardware store. Arduino, a little bit of this LED 2812 strip, and a couple of old meters that I got at a swap meet. Let's see if we can turn this into this. So I've got some of the parts I've broken out here. Roughly, I want to take these three 1-inch PVC end caps and place them something like this. I've made some little blocks of styrofoam. Eventually I'll cut this out of clear acrylic, but this is just an easier prototyping item. And they'll sit in something like this. As for the size of these, I made them 35 millimeters, and the reason they're 35 millimeters is because 35 millimeters is the distance between 5 of the LEDs on my LED strip. I'm not sure if that's easy to see or not, but 5 LEDs is about 35 millimeters, so I'll be able to get 5 in a row underneath the acrylic blocks. I'm not super happy with the height of these items. I think they're a little bit too tall. Likewise, for the top caps, I took one of these silicon spark plug caps and trimmed it down a little bit. I think that fits a little bit better inside this model. So I'm going to take these out to the garage, and I think I'm going to knock about 10 millimeters off the top of this and sand off the top of the labeling that's on there, because I don't think we want that either. Plus there's a little bump on one side. It's kind of hard to see under the camera. So we'll get on to that. Well, I've drilled some holes in the plate. The additional hole here, that's just to pass wires through once the cover goes on so we can light things up. Should look something like this. It seems like a really large bolt, but there's a reason behind it. Figure we'd do that, and then this can just pop on like that. We'll take this little bit of cable TV wire, poke it in the hole. Made that nice and tight so it won't go anywhere. And I think we're onto something. I think that's the beginning of some serious time travel. Let's get this outside and get it painted. So here are the two caps of silicone that I made and painted using different paint methods. This is the one using the craft paint, and it flakes off, and just any kind of movement to it and you can see that it just falls apart. And I spent a bunch of time trying to get this right. However, this is the one that was done with a mix of caulking, paint thinner, and some enamel paint, and it's perfect. You can bend it, it doesn't crack. Now, neither of these have a particularly great surface finish on them. I wasn't really going for that. It was just sort of more of a test. But this is what I ended up using in the end. Worked way better than the craft paint, which just flaked off. Well, it's time to replace the styrofoam mock-ups with actual clear acrylic. I've got this block here of 10 millimeter thick acrylic. That's just under ½ an inch. And I want these things to be about 35 millimeters long, which holds 5 of these little LED strips. So just going to mark this out roughly on here, take it out to the garage, I'll cut it, and then we'll sand all 3 of them down to being exactly the same size. Let's have a look at the software that's required to drive these WS2812s, or NeoPixels, as Adafruit like to call them. The first thing you want to do in your Arduino software is bring up the library manager. This takes a little bit to load, but we're going to make sure that we have the Arduino, or the Adafruit NeoPixel library installed. So when this finishes loading, we'll just search for NeoPixel. And we can see that it's installed right here. If this isn't installed, I'll just show you on another library. You just have to click this install button over on the right. But once it's installed, that's good. Let's look at the software. All we've got here is the number of LEDs, which pin on the Arduino it's hooked up to. We define a couple of variables as to the next time we're scheduled to update the LED string, And this is just a counter that counts 1 to 5, or in fact 0 to 4. We set up the string here. We set the length, which pin it uses, a couple of options. These are pretty common options. Again, I don't want this to be a tutorial on the 2812s, but give you an idea of what's going on. This setup section on an Arduino, this runs once. We just schedule the next update to be 0, so it'll happen right away. LED step, we're going to start at LED 0, like I said, 0 through 4, and we clear the string. In here, we get the current time. We say, is that time greater than our next update, our next scheduled update? Yes, it is. We clear the string, we set it to full brightness, and here we set the 0 LED to white, and we show that. The next time we're going to use LED 1, so we'll go from 0, add 1, mod the length so it doesn't exceed 4. It'll be 0 to 4, 0 to 4, 0 to 4. We say the next update will be now plus 200 milliseconds from now, or this will happen 5 times a second. Some people use delay loops. The reason I use this will become obvious when we get to doing a little bit more. But we just upload this code, and hopefully this is hooked up to pin 6. This starts counting through. Now it's a little bright. Let's bring the brightness down so you can see that. It's pretty effective. Next, let's have a look at what we can do with a meter. Let's look at what's involved in making the meter work. To start with, we have the meter hooked up. The positive wire goes through this resistor to pin 11. Now, pin 11 is one of the PWM outputs, or the sort of analog outputs, if you want to think of it that way, but pulse width modulated. The other side is hooked to ground over here. We need to calculate what this resistor is going to be here, but it's pretty easy. You divide the voltage, which is 5 volts on an Arduino, by the maximum amount of current. Now, the meter says right on it, right here, 50 microamps, or 50 millionths of an amp. So 5 divided by 50 millionths is 100,000, or 100K, and that's what this resistor is. Brown, black, yellow, 100K. On the software side, we've taken the previous software. I don't have the LEDs plugged in right now, but it's the same software. We added the meter pin. We're going to use pin 11 on the Arduino. Again, you need to use one of the PWM capable output pins. There's, I think, 6 of them on an Arduino. The only real updates we add is we add the bits for the meter in the setup. And then at the very bottom here, we have a little schedule update that says, should we update the meter? And we set it to a random number between 100 and 250. And if we upload that piece of code to the Arduino, we should see a happy meter jumping back and forth, making it look like we have some value that we're measuring. So let's put everything together. And to that note, rather than having an Uno with a bunch of resistors hanging off the end, what I'm going to do instead is I'm going to use a smaller Arduino Pro Mini. Now this is all of the same goodness that's on an Arduino Uno, but in a much smaller package, but it's programmable using a serial adapter. Now you combine now the Nano, which is probably a better choice for this, but I happen to have some of these lying around, so I'm just going to go ahead and assemble it using this. Going to put it on this proto board, and I'm not going to discuss the whole assembly. I'll put up a schematic, shows exactly what we end up doing. We have the 100K resistor for the 1 meter. I needed 360 ohms, and I didn't have 360 ohms, so these two resistors make 357. It's a 330 and a 27. I'm not going to drive the LED strings directly. They recommend you go through a small resistor. That's what this is, 120 or ohms, or 220 ohms. And also I'm going to add another capacitor in the power supply. This is 470 microfarads, just to smooth things out. The whole thing is going to be powered off a USB port. So I've just got an old USB cable that I cut off something that was getting tossed, USB on one end. If you break it apart, you'll see there's 4 wires. And of those 4 wires, Black and red are power and ground. Pretty easy. Don't even have to buzz it out. So let's just get to putting this together. Well, we've replaced an Uno and a bunch of things hanging off it with a somewhat smaller Pro Mini, everything nicely, neatly mounted, tied down, won't go anywhere. All that's left to do is the final programming. Requires a little serial adapter like this, but this is just temporary. You only need it during programming. Plug in the USB cable, which just fits. And we upload the sketch. Done. Now all we need to do is test it. And to show that it's not connected to anything else, we'll hook up the lights here. And we'll hook up one of the meters here. Plug the whole thing into a battery pack just for testing. And press the button. Can't see it very well, but we have chasing lights and we have a dancing meter. Next stage is to put all this together in the box. And on to some final assembly here. Got the plate. We've got our gold caps. Off camera, I've taken the little acrylic pieces and I put a little Kapton tape around them just to make sure that these electrical connections don't short out on the bottom of the plate. Plate's painted, probably would be okay, but anyway, so the way this is going to go together, pretty straightforward. Each one of these has a little tiny notch, maybe you can see it like that, that I filed out. Can't remember if I showed that in another video. That'll just sit like that. These go underneath. I've scribed in pencil very lightly. Actually shows more on the camera than it does in real life. The center line of what I want to line things up with. So I'm just gonna get these caps, wires through the grommet. And it's just 3M sticky back on here. Hard to see, but something like that. I've left the protective paper over the edge of the acrylic still. That'll be the very last thing that comes off. Likely because along the seam here there's a little bit of white, and I'll probably just go over that with a tiny bit of paint or with a black marker. Something like that. Those don't have to be tight. Not particularly good adhesive. This probably means I'll have to find some alternate glue to hold those down. Let's see what happens for now. These three need to come together and we'll solder those up. I'll get that ready and we'll get back to this. I think that's a pretty successful test. Now let's get this put together nicely. Here's a little problem I didn't expect. Because the original panel at the bottom was thicker plastic, the screws are now too long. Luckily, in my bin, I was able to find a couple of screws that were just a couple of millimeters shorter, and that was perfect. And they were black already, so they hide themselves, I think, even better than the painted ones. So the other thing we're going to have to address here is this is just too loosey-goosey. This is going to fall off, so we're going to have to glue that down somehow. Oh well, next task. Well, this one, the other two are fine. For some reason, this one just won't stick. So I'm going to use some of this dollar store CA glue. I really like these little pouches. They're 1 milliliter, I think. And they're basically one use. When you use them, cut the end off. But because that's such a small amount, I'm just going to throw it out when it's done. We'll stick some on the bottom. And of course, as I squeeze this, I realize this particular pouch is completely hardened inside. Maybe I don't like these so much. I always keep, this is a slightly different brand, so that must have been a really old one. How's that? These are really old pouches of glue. I'm not sure this one's going to work either. Doesn't look like it. Oh, is this going to be my downfall? That worked. Got everywhere, unfortunately. I'll just stick this on here. Get rough spacing. And that'll go down there. Unfortunately, it's sticking everything except what I want it to stick. Hold that down for 15 seconds. As you can see, I've got it absolutely everywhere. And hopefully that'll stay. Wow, that was a good one. We'll just get rid of that off camera. Been too long for the other ones. But that's not going anywhere now. So that's good. One thing it didn't do was stick. Well, let's hope that stays in place with a little bit of time. But I'm pretty happy with this fluxing. When we do the final assembly, these will sit on like that. I think that's going to look pretty damn good. So, off camera, I drilled these down a little bit. That'll just give us some more play to put things through. There'll be a final little bit of touch-up black that'll be required. A couple of spots where you see things. The bit I don't like is along the edge of these rails. You can sort of see the white of the LED strip underneath. So we'll touch all this up at the end before we peel off the paper on the side. But I think that's pretty successful. I've taken the lid, put some masking tape on it. Just that'll help protect it. This lid seems to scratch and scuff up at any little sign, so let's just protect it while we're doing the rest of the assembly. Well, it's time for final assembly, and I think I want to put that one in the middle, that one on the side. That's kind of how I laid it out, just to balance out the square with the round. I don't know, I'm not an art person. So let's put this in place. That's going to live like that and be held in place by this. So hopefully we can just tighten those down, and that'll hold it in place while we're working on it. That seems to work fairly well. Then this meter drops in here. Those holes are not quite right. Yeah, those are going to have to be drilled out a little bit more just to make it fit cleanly. How about this one? That one drops nicely in there. And this one is just going to be held in with 3 screws like that. Not sure I like the silver. I'll probably end up painting those as well. But we'll need to go out to the garage and drill those out a little bit more, and we'll get back to this. Okay, we're back from the garage. We should be able to just drop these in place. Yeah, that fits nicely. And that one now fits nicely. These will be held in relatively easily. Let's just do one at a time. This is held in with a couple of nuts that, of course, I've lost on my bench. Where did I put them for safekeeping? Right there. It's a relatively small mounting pegs on this 1 meter, probably a North American number 4. Well, that's 2.5 millimeters or so. For those of us that tend to use metric. Here in Canada, we're stuck between metric and imperial, with the economy being driven by the Americans to our south. So we get a often uncomfortable hybrid of measures. That should sit in from underneath. So that's take these from the other side. But it looks something like that. If anything, I'd say that milliampere meter is ever so slightly off square, which is annoying to me. And that's what happens when you just eyeball things. It might be annoying enough that I go fix it. It's 50 millimeters on that side, and yeah, it's about a millimeter off square. I wonder if that's easily fixable. Probably. Let's see if we can go fix that. There was actually just enough slack in the screws to just twist that the degree or so it needed fixing. The electronics is going to be pretty straightforward. I'm just going to mount the control board on the back here somehow. Probably something like this. The other thing I'll do is I'll take one of these cable ties and I'll put it on this particular nut right here. That'll help hold it in place. This allows for the electronics box to be swapped out pretty easily, and just some double-sided sticky tape. We'll take the wiring for the meters and we'll run that neatly, I don't know, somewhere. So let's get that stuck down and see which way this is going to work. Maybe this will work better this way. Something like that. I just want to make sure that the USB power cable has some strain relief on it. Well, I've got most of this stuck down here. I'm just going to use some of this nice double-sided sticky tape on the back of the PCB here. Cut off a couple of strips about this size. This is really amazing stuff. I love having this around. It's not the strongest. I mean, it is not 3M command, but we should be able to just stick this down onto the back and it won't go anywhere. It'll certainly be strong enough for our application. I'll zoom in on what I did with the... maybe I don't even need to zoom in. That'll just sit right there. That's wonderfully solid and not going anywhere. I mean, we'll run these neatly along here and up to each meter. That'll go neatly like this. Over here, let's zoom in. You can see I've just tied a little knot in the cable and run that through the cable tie. That will stop this from going absolutely anywhere. So that's a pretty good strain relief. Well, I'm getting ready to put these in, clip on and just poke through the holes. The paint on these yellow wires is pretty flaky. This craft paint is not the best. You can just see it flakes off when you bend it. So what I'm going to do is I'm going to pre-bend all of these and then just give it one last lick of craft paint. I don't know if you can see the cracking on that. Anyway, I'll give it one last lick of paint on the outside. It dries very quickly, and then we'll get these put together. Well, it's time for some final assembly. These little yellow arms, we can just poke through here and into there. Trim up just a little bit. Trim off a little bit at the bottom to go in the hole. Paint flakes a little bit, as you can see on the bench here, but it's fine for this application. Once it's in, you won't notice it. The paint on these other caps was quite the ordeal, but the silicone trick solved that. Little adjustment and just take off a little insulation near the end. think that's looking pretty good. We can finally peel off the excess paper on the side. Off camera, I cut 3 pieces of 10mm acrylic rod, drilled a small hole down the middle of each section, and glued in a piece of copper household wire. These just add the final touch. We'll hold these in with a little bit of hot glue. With the final few screws here, we're ready to test and see what it looks like completed. For details on all the parts, links to the source code and more, check out the description below. And if you like this video, remember to like and subscribe for more.